Okay, first let me check the teams. So thank you Aska, Kevin, Ilham, and Christian who has submitted. So the one who hasn't submitted, please. What time? How many time? How many more minutes do you need?
I have submitted at 10:02, so it's late.
Okay. So let me just refresh them. Okay, good. So it's Helena, Dama, Ayu, Kevin, Fatia, yeah. Okay. Right. Okay. Um, Now let's discuss the result, and after that, let me have a quick check about your work. So at least you know which one you need to uh, improve. Okay. Okay, so actually I took it from last year's exam. Okay, so this is an example, yeah. So this is from last week, so from last year's marking. Okay, so for example, this is the one number is 100. Okay, and then there are the passing limit, which is syarat lulus, ya, and then it is 70 up to 100. Okay, so usually the syarat lulus, it should be until the part D. Okay, so if you can do it until, usually it's always until the shell momentum balance, and then you got the boundary condition. Okay, and then after that, it is usually it just if for example you don't pass this one, the part E, that's fine. You still can pass the exam. Okay, but if not, then you have to do the remedial test. Okay, so of course I really don't want you to do the remedial test, so it's very important for us to make us understand regarding this one. Okay, so here so let me make it bigger. Okay, let me go over here. Okay, so the number point A, determine the initial point O of cylindrical coordinate. Okay, so this is for example, this is the answer. Yeah, you should write it with the axis and r axis, and then write also this is r equal to 0, and this is r equal to r, this one z equal to 0, and over here is z equal to L, for example. Okay, so here you need to have a correct point, titik yang benar, the correct direction, arah yang benar. Okay, and then the second one, sketch the velocity profile of the liquid on the picture. Okay, so this is for example part B, velocity profile VV, and then it is a falling film inside the inner wall of vertical pipe. So you know that on the on the surface of the liquid, and then with the atmospheric air, you have a velocity. Okay, and then in the wall, it is the velocity is 0. So, and it's a parabolic, and it's also with the the positive direction with the z direction. Okay, so it's a z direction. So here you have to have a good sketch, sketsa yang benar, and it's on a parabolic, and then also the direction with respect to positive z. Okay, that's number 2. This is 10 points. This is 10 points. Okay, and number C, draw or sketch a differential room that will be used for the momentum balance. Write or note the momentum component in and out of the shell, as well as the position of in the thin shell. So yeah, I think we know this one. Yeah, the minus the input and the output, and then you need to write the position also, and then the component in and out, this one also. Yeah, and this is a 10. Okay, and after that you got the which one is it? So it is the D sorry the D the shell momentum balance assuming a steady state. There are 20 30 40, yeah, so about 40 points in a point D. Okay, so you have to write the momentum balance. It is similar of course with the cylindrical tube, so even it is if it is open book, you can just open the book or open the notes or open the PPT and then check it, try it or by yourself like this. Okay, and then we also learn about the physi, the pressure and also the tosity. One of very important things that the pressure is actually is similar. Okay, sama in Z equal to 0 and Z equal to L, because the pressure is it is an open system. Okay, so the pressure in here and in here at the certain R, it is similar. Okay, so the pressure is not a function of V. Okay, it is different with the cylindrical tube where the pressure is function of hydrostatic pressure, yeah, with a function of V. Okay, and after that, see, so karena sistemnya terbuka, so the P when Z equal to 0 equal to P when Z equal to R. So here we wrote that if you put there is P 0 minus PL, kalau ada tekanannya, so it is it's not pass the test. Okay, you don't pass the test because it's all about concept. Okay. So after that, you to find the this one, okay, this one here, and then the boundary condition, syarat batas. So we know that the boundary condition related to the flux, the momentum flux, is when on the border here, or when R equal to delta, the tau is equal to 0, which is the interface of the fluid and the air. Okay, interface fluid dan udara. Okay, and then you got the C, this one, and after that you add the C over here, put it into here. Okay, this is negative. Okay, or any variation that in any form that you think that it is logically you derive it from this one. Okay, so this is the momentum flux distribution. Okay, and after that, number E, it is shear force, yeah, derive the expressing the shear force applied. So shear force in Indonesia is called gaya geser pada dinding pipa, yeah. So the shear force would be the force, the shear stress at the inner wall multiply with the area. Okay, so this is the shear force and then multiply with the inner wall. Okay, so here we have 70% point for syarat lulus, and then another 30 point for to make you equal to 100. Okay, so so if you it is written 30 minutes with 5 minutes, so you really need to think how to make it yeah, maybe make it faster or like something like that, yeah, because the thing is, if you still can't pass in that certain time, it is even you can do that, it is also difficult for you as well. Okay, any question?
No, for question C,
Yes.
do we have to draw it in 3D or in 2D? Is it enough?
C, this one, that's fine. 2-dimension or 3-dimension is fine, as just you have to get all the direction right. Yeah.
All right, Ibu, thank you.
Okay, any other questions? No? Okay. And then we have the second number, but the second number is about I think about the second number is about equation. So I just want to give you an example. This is an example of what happened in the next chapter about the equation of change. So you will have a lot of equation like this, and then what you need to do, you have to eliminate it, which one is right or not, and then you get the real the equation. But later on we will try to solve this type of equation later on after we finish the equation of change. Okay, now I will quickly open your squeeze, so I can have a feedback for you. Okay. Okay. So I think the problem that we have is actually I know the students doesn't have feedback on time. Yeah, so you get the feedback late, and then so you don't have time to try to improve it. Okay, so Nadifa, okay, so that is number A. Okay, good. B, also the velocity profile. Okay. The momentum shell balance. I don't think I didn't check really detail, yeah, but we're gonna see. Okay, so this is the integration. Yeah, looks right. And then you find the boundary condition. Yeah, this is also right. And the shear force, tau RZ, and then A. Yeah, okay. Yeah, looks. I don't check the detail, but it looks right to me. Okay, so well done. And next, Elena. Okay, so Elena, let's make it bigger. So okay, this looks right. The number A, the coordinate looks right. The velocity profile, yes, you can write it here if you want, but if you make it separately, okay. And then this one, okay, Helena, if you think that because you make this one the shell, please make the shell also similar to this picture, okay? Because you make the shell looks like a thin cylinder, a thin shell of the selongsong, yeah. Okay, Elena. So when you make if you want to do it separately, don't make it like a block. Okay.
Noted, Bu. Thank you, Bu.
Yeah. Okay. So you need to just redo this one in here. Okay. Because if you look at here, me or the assistant will will think that, okay, why you make it like a block. Okay. Even though this part and that part is fine. Okay. But you just put it in one side. It's fine. Okay. And then part D, shell momentum balance. This one's cancelled out. You have to really write how you get this limit. So you have to write that this part divided by what. Okay, so this should be divided. Oh yeah, this one. Yeah, divided by 2 VRL. Oh yeah, okay. This one. Oh yeah, okay. That's, you get it right. TC1 and R looks right. Yeah, I think this looks right. Okay. Okay, I think that's good as well. Then Sodama, let me check. So this is an open system, so that you write the assumption. Okay, that's good. The number 1 is okay. This one you have to make the profile, Dama, so make the profiles, to make the profile like the parabolic way, you sure that there would be no no velocity in here, and also the maximum would be in here. Okay, Dama, so make the profile, the parabolic profile. Okay, hello, are you there?
Got it.
Okay. The one that you're missing is the
Yes, can you
shell.
hear me, Bu?
I can't hear you. Hello. Dama, are you talking? Hello. Hello. Okay. Anyway, okay. So if you can't talk, Dama, please listen to me. The things that you're missing is the okay. You miss something. You miss the thin shell. Okay. So the thin shell should be between, should be between those those flow here. So for example, let me check with the Helena one, or with the Aska, yeah. Okay, so here, so this is the this is the wall. Okay, so this is the fluids. So this is the thin shell. Okay, so you have to make the thin shell, which is start from x to x plus delta x. Okay, yeah, Dama. So I think you're missing that one. To here. Okay, so you're missing the thin shell. Okay, so at the moment you can pass. Okay, this one, yeah, so you're missing that one. So how about this one? Let me check the shell balance. Okay, so again, you need to make sure, because this is open system, right? So PL equal to P0, then you don't need to write this P, the P over here, okay? Because this is cancel out. Okay, so you don't need to write the capital P over here, because you said it here in the beginning that it is an open system and downward flow. So the one that is still there would be about the rho and G, yeah, rho G, and also only R. Okay, so I think you have to recheck again, yeah, the work. Okay, Dama, and this one, and then integrate. So you get the you got the C1, and then I think you haven't finished with the boundary condition. Find the boundary condition, and after that the force, the shear force. But at least the good thing about this, you know that, okay, what is your speed at the moment, and then you can try to improve for the exam, how to improve the understanding and also the speed, so the time would be okay, yeah, for you when you do the assignment. Okay, thank you, Dama. Well done. And then Ayu. Okay. So I think okay. So this one, yeah. Points, velocity profile. Okay, this one. Yeah, this okay. This one, the velocity profile. Ayu, you need to also to draw the the graph, yeah, the graph for the parabolic one. And then I think it would be good, Ayu, if you can draw using the ruler, and also make it quite large, okay, and then so you can point all of them in that one, okay, rather than write in separate spaces like this. Okay, and then even if you put the thin shell over here, but actually the thin shell is also over there, because it is two sides, right? Okay, it is two sides. Okay, Do you hear me? Hello? Are you listening?
I think she replied in
Oh yeah,
the
okay. Yeah, okay. Yeah. Okay, so and then don't make it like this as well, okay? So you have to make it look like apa? Selongsong ya, look like a pipe, and then it's cut into two. Okay, it's very important because it is a concept. So yeah, okay, and then be calm. Okay. Uh, right. Additional momentum balance. Yeah, this one is okay. P equal to PL, steady state laminar. You got that one there, okay. You have to write the shell momentum balance from the beginning, yeah. So this one, don't write just up to here, but write the shell momentum balance in and out, and then with the gravity, and then after that you can derive that one, okay. I think this is like as well so you for this case you haven't passed, okay. And then this one looks right. This one looks right. I think F also, it is also same, yeah. 2VR, yeah. Okay. Yeah. Okay. So for Ayu's case, even you got it right, so maybe you can get the force, the 30 points, but you didn't write the complete mass balance in the beginning. This one, the mass balance, so it is syarat lulusnya tidak terpenuhi, ya. So to make sure that you put all the shell momentum balance. Okay, Ayu, well done. So try to improve it for the next one. Need to improve it, of course. Kevin.
Bu, I think I uploaded something else, Bu, because I did A and B really wrongly. Bentar.
Okay, but anyway, you know the feedback from others, yeah.
Yes, Bu. Also, Bu, I have another question, Bu.
Yes.
I'm confused. How do you know that it's an open
Huh?
system, Bu? How do you know that it's an open system?
It's open system
Like,
because you contact with air over here. There is air.
oh, okay.
Ada udara.
I thought it's just another shell, you know. So the fluid is like flowing inside two
Ya.
different shells.
Ya, apa? Melapisi turun di pinggir-pinggirnya aja. So this one is hollow. Okay? Ya. Okay.
Okay, Bu.
Fatia. Okay. Very very interesting, Fatia. Why you put it here?
I thought it would be in the middle.
No, it should be in the beginning. It should be start from z equal to 0. Yeah. Z equal to 0 and z equal to L. Yeah. And then the thing is, I would like to write also, if you let me write it here. If the R is actually if this is the axis, okay, and this is the R axis, the theta is not that way. The theta is about that way. Jadi dia muter ngelingkerin jari-jari. That is theta, like in angular motion. Okay, so the theta is not in this way. Yeah, if you want to write the theta. Okay, so but if because it's about cylinder and then it's about one side, that one you don't need to write the theta. Okay, yeah, so the theta is in that direction. Dia muter. Okay, not like this one. It looks like Cartesian diagram. Okay. Next. Okay. Let me close this. Okay, so the velocity also you have to write the can I write it here? Okay, so yeah, the velocity you also need to write the profile just to make sure that there is no velocity on the wall. Okay, and this one, nah, if you want to write it like this, you have to write it in two piece ya, two sides, kiri dan kanan, because it is selongsong ya, selongsong kayak don't have a paper here, maybe this one. Yeah, this is selongsong like this. Okay, so when you cut it in 2 dimension, you will end up one slice in here and one slice in here, right? So again, you need to write it twice and don't write it like this. Okay, yeah, Fatia, yeah.
Okay,
And then
also for this one, Bu, I forgot to write not the part D. I forgot to write the full working out because I was running out of time. So
okay.
I think I'll
So this
upload
one,
the
yeah.
full one.
Okay, so the shell balance you do best. Okay, right. Okay, this one is okay. So at least you have got the feedback from me, and then even though you do it now is 1 hour, is actually maybe prepare for 30 minutes. so you can make more practice about this one, yeah. Okay, Gamma's not submitting. Alisa. Yeah, Alisa, okay. Wait, add. Okay. Alisa, you really need to make sure that you put it is 0.0. This one is not 0.0, just but slightly up there. But even you write, put it here. So just like put it here, okay? It should be at L equal to 0. Okay?
Alright.
This one's okay. This one's okay with that one. But again, put the profiles. Okay, number 2, and then you write that one.
To be honest, for D, I haven't really finished it because I was so confused. But
Oh, okay.
I will
So
do it.
still running out of time, something, yeah. Okay, yeah. So you can try it. Maybe learn with your friends or others, yeah, about to try to finish this one. Okay. Ilham. Okay, so Ilham, there is no fluid in here, yeah? So it is good up to here, but here there is nothing here, so don't write it like this, okay? Ilham, are you listening to me?
Yeah, but I was a little confused on the diagram.
Oh, okay, yeah, so basically this is a fluid, okay? And then, yeah, this one, there's nothing in here, yeah? There's nothing, so the wall of vertical pipe is wetted, terbasahi, with the liquid that flow downward with the film thickness of delta. So this is delta, so there's nothing in here, okay? So hopefully you have more understanding that one. Okay, and then this is the point. This is the VR equal to 0. This is okay, and then the thin shell, you also haven't make the thin shell, that one. Yeah, okay, so still I need to check. All right, I think I hope you don't feel bad with me opening your assignments. This is just to make sure that you got the feedback, because we haven't got do the online the offline class, but yeah, this really to make sure that you at least where you're lacking, and then what to improve. Okay, anyone would like to have any questions? Okay, so do we have like I'm just wondering, so it looks like maybe some of you doesn't have the phenomena, yeah, that doesn't got that phenomena yet, yeah. Right. Okay, now let me open, if there's no other questions, I will open the screen. Wait. Wait, give me 1 second. Where is it? Oh yeah. Oh, not this one. Okay. Hopefully from the feedback, you know what is you're lacking and then how to improve it. And then also, for example, another type of question would be, for example, about the falling film, like with incline, bidang miring, or what happen if the fluid is not inside but it's outside, luber, yeah. If you have, for example, what happened, another, maybe let's open. Okay, for another example, for so in this case, we have the fluid falling inside. Okay, and then another example, it can be that this is the cylinder, but then the fluid is for example, it is full over here, and after that, apa tuh, luber ya, it's like falling off that one outside the pipe. Okay, and then it also, for example, with this R, and then this is also a delta, for example. So at least you need to have you need to imagine what happen if the fluid is jatuh keluar, ya, this one, and then it's flowing outside. Is it open system or closed system? But we're looking at the outside liquid. We interested with this flow. What happened? So rather than it is inside, it is inside the wall. This one is outside the wall. What do you think? Is it a closed system or open system?
Open,
Miss?
Open. Okay.
think
How about
open.
others? Christian?
Open, I think.
Open. Yeah, so you have to think about the fluid that you looking at to get the profiles, and then check that fluid is that open system and closed system, because we're interested with this part of the liquid, so it is open system, okay, because we see it is atmospheric. All right. Now let's continue with the next one. Okay, so about the shell balance here, we learn about the equation of continuity, and after that the equation of motion, and then also equation of mechanical energy and also angular momentum. Okay, and then you need to open the flux, yeah, the equation of change, and then in your separate in your laptop, open the PDF for the books and then see the appendix B. Okay, so this is the equation continuity. This one, they are with the, if you use Cartesian coordinate, use this one. If you use cylindrical, use this one, and if you use spherical, use this one. Usually, in this class, we use most of them Cartesian and also the cylindrical coordinates. The second one, if you remember from on Wednesday, we know also about the equation of motion in the term of shear stress. Yeah, there are the Cartesian coordinates, cylindrical coordinates, and also spherical coordinates. And then the equation of motion with all about the temperature, with all about the velocity. This case would be also. Okay, and then let me open one more. I would like to give you an example about wait, should be about let me check with this one. Okay, I think for one more, let me just let me close this one, and let me just open it with over here the wait, let me open the book then. Okay, so this is the book, and then let's open to the part 1, momentum transport, chapter 3. Okay, and then I would like to explain to you about the equation of motion. I think in wait. This one. Okay, so this one. So let's open. Let's try again. Check again with a circular tube. Yeah. Rework the example 2.31, which is about the flow on the cylindrical tube. Remember? Okay, where there is a cylindrical tube, and then let's try to solve this, but using the equation of continuity, okay, rather than using the shell balance. Okay, so I think I have to copy. So here in here you can see that actually if we use it using equation of continuity, I think I need to prepare all the equation first from the appendix B, and then so for example, let me open back to the 2.31. Yes, let's open back to the cylindrical shell case. This one, the flow of circular tube. Okay, let's try to do this, the circular tube which is flowing, but with the equation of continuity and also equation of motion. Okay, so with this one, if you see about the coordinate, we know that the coordinate is the coordinate of the cylinder. Okay, so the coordinate of cylinder, so what you need to do, you check the equation at the for the cylindrical. Okay, so after that, so to solve using equation of continuity, we have to you have to open your appendix B, and then in appendix B you need to check the equation of continuity and equation of motion for the cylindrical coordinate. For example, this one, this one, yeah, the equation of continuity. Okay, so for equation of continuity, you select this one. Okay, so in the cylindrical case, in the cylindrical flow inside the cylinder, like the full one, let's consider the full one. Do we have dou rho over dou t? Do we have a change of density with time? It is steady. So do we have a change of density with time?
No.
No. Okay, so this is 0. Yeah, we cancel out. Okay, sorry, I can't write in the book. So, maybe I can draw today. Draw something. No. Yeah. Okay. Okay. So this one I can't. So this is cancelled out. How about and then there is 1 over r dou over dou r rho r phi r. Do we have phi r? Phi to the direction of r. Remember in the cylindrical coordinate, and then the flow is just on the v direction. Do we have velocity to the r?
No.
No. Okay, so this one also 0. Okay, do we have phi theta?
No.
No. Do we have dou over dou z to rho phi z? Do we have a change of phi z to the z? Do we have change of velocity in the direction of z with the z?
No.
No.
It's
Okay.
only R.
So for the equation continuity, both side is 0. Okay, so we don't need that. Okay, so this one is make so all of them we just need to do the coret-coret. Okay, the second one is the motion. Yeah, sorry, the equation of motion in the term of it can be in the term of theta. Yeah. Stress, the tau, or in the with the second one without this one. Okay, there's a cylindrical coordinate or this one. Okay, let me check again what they use for this one. Okay, so they use this become the equation of motion, this one, yeah, equal to the phi. Okay, so then here, so if you look at here, so the equation of continuity, the dou vz over dz equal to 0, yeah, which is the same that we checked before. If you want to look at the r and theta, that's fine, but of course that won't be any changes. And then the last one here is the z equation of motion. So let's have a look back into the appendix B. Should be appendix B, this one. Okay, let's try maybe you looks with this one. Okay, so here this is the cylindrical coordinate. Okay, it can be with in the cylindrical coordinate there are 3 lines. Okay, the first one, if you look at over here, look at the back there, row GR. So the row with G with in the direction of R. So this is in the R direction. This one G theta, which means that it is in theta direction. This one on the Z equal to at Z direction. So we're looking at the Z direction. Okay, so let's try check again the one that we can cancel out. So this is dou phi z dou t. Do we have this value? Is it steady? So it has a function with time. If it is steady, do we have a change with time? The velocity?
No.
No? Okay, no, yeah, because it is not a function. It's not because it's steady. We don't have a function with time. We don't have VR here, so it is also cancel out. We don't have theta. It's cancel out. This one also phi z over dz is equal to 0. The previous one is also cancel out. Okay, so this part is equal to 0. This is dou p divided by dou z. Do we have a change of pressure with direction of z? We do, yeah, we do have this one. So and then this one is mu and then 1 over dou r. Do we have the dou phi z over dou r? We have the change of velocity with the r. Okay, so this one we have the value. This is a second derivative. A second derivative. It is of course equal to 0. Yeah, because it's second derivative. Because if the first derivative is 0, of course the second derivative would be 0. Yeah, and this one also equal to 0. So it's basically the one that have the value is minus dou p over dou z plus a mu 1 over r dou per over dou r dou phi z over dou r plus rho g z. Okay, so when I open it back to here, this one is the from the equation of motion. Okay, so by looking at the tables and then to cancel out all not the one that is not applicable to that one, we can get information about this one for the equation of continuity, and we also get the equation of this one. And after that, we can find the boundary condition. Okay, so we can make the boundary condition. Maybe so we can do the integration here, the second integration. Okay, and then find the boundary condition. Okay, so we have the 4 boundary condition at z equal to 0, p equal to p0, at z equal to l, p equal to pl, and then r equal to r, v equal to 0, and at r equal to 0, phi2 is finite. Okay, so with that one, if we submit it into here, then you will end up also with this one. Yeah, with the and the result would be similar with the shell momentum balance. Okay, so okay, I think that will give you some application of equation of change. Next week we'll go through with more examples of the equation of change. I hope you can prepare your appendix B. Yeah, at least you can prepare with a piece of paper or put it in your Word or in your tablets, and then copy all of the formula in the appendix B, and then we'll have a practice again how to try to do it this one. Okay, so practically we can solve any problems, even more complex problem, easier. It's not easier because with the equation of change. Okay. All right. Any question, please?
Ibu, I'm just wondering, is the exam soon, Bu?
Yes, should be at week 7 or week 8. So still about next 3 weeks or next 4 weeks.
Okay, Bu, thank you.
Yeah, so just to make sure, let me check the files because the exam should be in the, it should be offline, yeah. It should be offline. Okay. Can you see my screen now?
Yes, Bu.
Okay, so let me check. So where we are. Okay, so we're here. We start with the continuity, persamaan kontinu and gerak, the equation of motion, and then also there's some turbulent. I'm sure that there would be another quiz, maybe in week 6, yeah, after we finish the chapter 3 or chapter 4, and after that we'll have ujian at week 8, but after that, at week 7, we'll continue to the energy thermal, energy balance. Okay, so I would imagine that in each module there would be 2 quiz. Okay, because one quiz we just done that with the shell momentum balance, and the second one we will do the quiz for the continuity. I don't know where's the quiz, so it's really up to the teaching you know, the teaching team. Okay, all right. Any other questions? Right. Okay, I think that's all for me. Thank you very much for listening, and then I hope my feedback can give you some notes how to improve again the time, the systematically. If you can do it with a coloring pen or I don't know, stabilo or something, that would be good to make it easier, and just be clear with that one. I really want everyone in this class should pass the exam. Okay, thank you everyone, and then see you again next week.
Thank you, ma'am.
Thank you, Bu.
Thank you, Bu.
Thank you, Bu.